All right, last example of the day here. Remember that parallel lines had to have parallel direction vectors. So when we talk about parallel planes, we need to have parallel normal vectors. So that means that our second normal vector has to be a constant multiple of the first one. Or the angle between the planes could be 0. They could be non-intersecting. So if the angle between the planes is, or 180 actually, if the angle between the planes is anything but 0 or 180, then they will not be parallel. So the way that we tell the angle between planes is we look at the angle between their normal vectors. And just remember the theorem that we had for the angle between vectors. That was just vectors a and b here. Well, this is the same thing. Cosine theta is a dot b over length a, length b. It's just we're using n1 and n2. So that picture would look something like this. So here's your first plane. And then you've got a second plane. Looks like this. And then we want to tell the angle between that plane, and what we do is we look at the normal vectors. So that first plane here, so you can kind of see, the angle, and we use the acute angle. So that's this angle right here. That's the angle between those planes. So the normal vector for this first plane would look something like this. And then the normal vector for this plane would look something like that. And then the angle between those two vectors is the same as the angle between the planes. They're just shifted 90 degrees. So let's find the angle between 3x minus 2y plus 6z equal 5 and x plus 2y minus z equals 1. So let's go ahead and list our normal vectors here. So the first normal vector, we can read it off here, 3, negative 2, 6. And then the second normal vector, we can read off here. This will be 1, 2, and negative 1. And so then the cosine of the angle in between those vectors is going to be the dot product of 3, negative 2, 6 with 1, 2, negative 1 divided by the product of their lengths. So the length of that first vector, this will be 3 squared plus negative 2 squared plus 6 squared. I just left off the negative because when you square it, it's positive anyways. And then same thing here, 1 squared plus 2 squared plus 1 squared. So let's see, this will be 3 minus 4, and then 6 times negative 1 minus 6. And then you've got down here, let's see me, 36 and 4, 40, 49. So square root 49. And then 4, 5, 6, square root 6. So let's see, 3 minus 10, negative 7 over, this will be 7 square root of 6. And our 7's cancel. So we get negative 1 over square root of 6. So that's what cosine theta is. So then your theta is going to be inverse cosine negative 1 over square root of 6. So let's go ahead and compute that on the calculator. I'm going to have my answer in degrees. So let's go ahead and go to our mode here and change to degree mode. So then we need a second function of cosine inverse cosine, and it'll be negative 1 divided by square root 6 close up our parentheses. So we get 114.1, approximately 114 degrees. Now we actually want to use the other angle here, the complementary angle, 180 degrees minus 114, which is 66. And that's rounded to the nearest degree. So we're always using an acute angle. So if you end up with something that's more than 90 degrees, you need to subtract from 180, get that supplementary angle. And then the last thing I'll mention here is the distance between a point and a plane. So if you've got point P1, so you got point P1 up here, and then you've got a plane down here that's got equation ax plus by plus cd equals by plus cd plus e equals 0. So that's your standard equation of the plane. And if we want to tell this distance right here, what we can do is we can take vector b, the position vector for that P1, and we can compute the length of the projection because this is going to be a perpendicular. So we got this vector going up here like this. That's our vector b. So that's a vector b different than this b here. And we're going to take and project that down onto the plane. Oh, well, that's just, this distance is just the component of that vector that's perpendicular to the plane. And remember, the component of b that's perpendicular is n dot b over length of n. And this is what that is in terms of the equation of this plane. So a little bit of algebra to show this. If they want you to find distance from a point to a plane, you can just plug into this formula. And you do not have to memorize that formula.